Yeah, 10 for 5 and then 10 for 2 cents. Yeah, 2.
Okay, what you should have written out beside numbers 1 through 4, you should have your inverse variation info written there real big out beside those. Anytime you see inverse variation, we talked about that's what you're writing down. Y equals your constant divided by your x. Now on this section 1 through 4, there are 2 blanks, and so that means there are 2 answers for each of these. Excuse me, the first thing it asks you to do is to write an equation relating x and y. So that means when it says relating x and y, that means your answer is still going to have a y and an x in it. You're just going to replace a with what a is. So in number 1, they tell you x is 7 when y is 2. So if you plug those in over here, that gives you 2 equals something divided by 7. Undo that division with multiplication and you get 14. So your first answer on number 1 will be y equals 14 over x. There's your first answer. You wrote your equation. Now the second thing it says to do is to use that to find y when x equals negative 2. So you're just figuring out what 14 divided by negative 2 is, and there's your second answer. So all of these will have an answer that looks 2 answers, one that's the equation like this, and then one that you actually solve.
So your first answer would be 14 over negative 2.
Just leave the x. 14 over x.
So the answer would be y equals 14 over x.
That'll be one of your answers, yes.
And then x equals negative 7.
Y equals negative 7.
Oh.
Okay, and you're going to do that same process for 2, 3, and 4. So let's get 2. 2 had some fractions or decimals involved. So we're going to start again. Come on, marker. There we go. We're going to start again with y equals something divided by x. It tells us that our y is negative 13 thirds. And our x is 9. So when we go to solve this for a, I'm being divided by 9, so I would multiply by 9. So I got to figure out what negative 13 thirds times 9 is. And that ended up being negative 39. You can check me out on your calculator if you need to, but I got negative 39 on that. So my equation, y equals negative 39 divided by x. There's answer 1. Now I got to plug a negative 2 in for the x. So y equals negative 39 divided by negative 2. Negative by negative is a positive, and 2 doesn't go into 39 evenly. So I just left it as 39 halves. If you put, what is that, 19 and a half? You put 19 and a half or 19.5, that's fine. Any of those equivalents are good. Okay. Numero trace, moving right along. Y equals a over x. So that would be 5 on number 3 equals a over negative 6. So 5 times negative 6 gets you your a of negative 30. So your first answer is y equals negative 30 divided by x. Then you plug a negative 2 in for that. So y would be negative 30 divided by negative 2, which would be 15.
So whenever you give me your first one, you can just divide that by 2?
Negative 2.
Negative
Yeah, and that's all. It'll be whatever. The test might not be the same number.
2. Okay.
So whatever number it is up there, yes, you just divide by that.
Okay.
All right, last one out of this section. We went to a purple dotted line there. Let's change that back. Y equals a over x, and we've got some fractions here. 5 halves equals a divided by 8 fifths. So a little bit trickier here. My a is being divided by 8 fifths, so it means I need to multiply by 8 fifths. So I got to figure out what 5 halves times 8 fifths is. Let's see, that would be 4, right? Because the 5s will cancel. 8 over 2 is 4. You can type that in your calculator if you can't work that mentally. So there's your first answer. Second answer, like Grant said, we're just going to divide by -2. There you go. Alright, on 5 through 8. We have something similar to this on every test that we've done all year long, but they changed the way they worded these. They actually made it easier, but the wording probably confused you a little bit. All it's wanting us to do is look at those graphs on 5 through 8 and compare those to what we know the parent function would look like. Every parent function that we've done, and including these hyperbolas, it's anchored around the origin. So we just got to be able to look at these graphs and see where they've moved left and right, up and down in relationship to the origin. Then we know left and right goes the opposite way of the sign, so we'll tell if our H is positive or negative based on the opposite way of the sign. We know up and down, our K gets the right sign. So if I'm looking on number, see, this is how I wrote these on my paper, on number 5, if I'm looking on number 5, the parent function would be centered around the origin, right? Number 5, they've moved things over here and down here. So to go from those 2 black curves to those 2 blue curves, it looks like that I would have to move left and down. Wouldn't you agree?
Wait, so they'll always be in the same spot? Those
The
two
parent
lines?
function, yes. Okay, so left normally means negative, but H goes opposite way of the sign, so this would have to have a positive H. K goes down, so K is negative. So that's all I put on number 5. You don't have to count and figure out how many. Read the directions up there. It just says determine whether the values are positive, negative, or 0. Okay? Wait. Okay. That's 5. There's 6.
Wait, why is K minus again?
Because to go from the black to the blue, I had to move down, up and down, gets the right sign. That's been that way all year long. We took the parent function, which is the black one, and moved it to the graph they showed you on number 5, which would be kind of like the blue one. Both of these black ones would have to go left and then down to get to where those blue ones are. Up and down goes the right way of the sign. Left and right goes opposite of the sign. Alright, so number 6, I've got my black ones drawn again. But then they've got one way up here and over here. Now, obviously, a flip has happened, but this question doesn't care about any flip kind of stuff. They're just wanting H and K. So what I'm going to envision here with my black ones, obviously my K's got to be positive. I've obviously got to move my black ones up, right? Now, what about left and right? What would you think on that? Okay, look, it's easier to look at on your paper than what I drew. I didn't draw it very specific. On your paper, are you looking at number 6 on your paper? That y-axis is not splitting them anymore, is it? They moved to the right side of that y-axis, didn't they? Look on your paper. See how they moved to the right side of the y-axis? So that would mean it moved right. So if we move right, that's usually positive, so our H would be negative. And then we all agreed on, we went up. What's my K if I go up? Positive. Alright. 7 tricked me a little bit on the H. Look at it on your paper. Okay, I'm not going to try to mess you up on the smartboard again. Look at 7 on your paper. Look at the y-axis, because that's its vertical asymptote. That's what's going down the middle. Has it done, like, moved to the left of that y-axis or moved to the right of that y-axis any? Isn't that y-axis kind of still in the middle of those 2 curves? So left and right, it didn't move anywhere. So that's why they gave you an option for your H to be 0. Okay, but compare it to the x-axis, the line cutting through the middle of it. I think it did drop below it, didn't it? So that means I had to go down, so my K would be negative. And that might be the easy thing for y'all to do, those of y'all that are still confused, is compare the curves to those axes. Did it jump over one, up or down, right or left? That'll give you a good idea. Because on your parent functions, these I've got scribbled up here in black, they never, the axes are the asymptotes, they never touch them. So if it moved over to the left of it, it's going positive, right? So y'all can figure out on that. Okay, one more, number 8. It's crossed over both of the asymptotes. Can you look at your graph and see it crosses the x-axis and the y-axis?
Yes.
Okay, so if it moved over to the left side of the y-axis, that's my h. What will my h be? Positive, good, CJ. It moved down below the x-axis. That's my h and k. What will my k be? Negative, fabuloso. Whoop, whoop. So not really a difficult section there, but the directions changed from the other tests, and so you might have struggled with the directions a smidge. You all right? All right, the next section there, 9 through 14, are my favorite ones, because that's where we get to do some ninja and possibly.
Yeah. I love it. I love it.
Gotta roll up my sleeves for ninja math. It's getting business, Michaela.
I don't like ninja.
You don't like ninja math?
No.
That makes my heart hurt.
I mean, there's nothing wrong with your aspect of it. I just don't like what I
I
have.
don't want to do it.
I like the ball. Me too.
I really like the problems where you get to bomb and ninja both.
Are those things? Have
Yeah.
you been doing those?
A ninja
Yeah.
Oh,
ball?
she wasn't here for the ball.
You need to watch the video. Alright, let me see here. I've scribbled all over my paper while I was working this out, so I'm trying to decipher what was underneath there. 3x cubed over 6y squared times 4y to the 5th over, is that 7x to the 4th on the bottom?
Yes.
I scribbled them out as I was working on doing my ninja math. Now let me say this, somebody yesterday in one of the classes, they just went ahead and multiplied across the top and multiplied across the bottom and then simplified that answer. And that's right, you can do it that way. So don't think you have to do the way I do it. Y'all need to know that by now. More than one way to skin a cat. How many times have I tried to encourage you to try stuff different? Don't do everything like I do. That's bad news. You'll be weird. So, but I'm going to show you how I did it. And then if you did try it a different way and got it wrong, we'll look and see. Because I want you to try do things different. So I just started reducing stuff that I knew I could. So here I had an x cubed on top and an x to the 4th on bottom. So if I reduce those, if I ninja those, the whole x cubed on top would go away.
You just have an X on bottom.
And I would just have an x left on bottom.
Wait, what?
X cubed over x to the 4th just leaves an x on bottom.
I know, but why?
You could. That's what I just got done saying. I'm just doing it in a different way. So don't give up.
I don't know if I did it
Yeah,
right. but I
I keep numbers smaller. So I reduce first so my numbers stay smaller because I'm a pea-brain and I can't do big numbers like y'all. Alright, so with my y's, I got a y to the 5th on top and a y to the 2nd on bottom. So I know the whole y to the 2nd on bottom will go away. And this will turn, 5 minus 2 is 3, so that'll turn to a y cubed. So far for my answer, I know it's got to have a y cubed on top and an x on bottom. What's that?
What is that number?
Okay.
X.
I scribbled it out.
No.
4. Because that was out of the original problem I was showing you my work on that. Okay, now what I did, and you could do this easy in your head, 3 times 4 is 12, 12 divided by 6 is 2. You could do that and get that, and then you got a 7 down here. What I did, I said 3 over 6 is the same as 1 over 2, right? 4 over 2 is the same as 2 over 1. So I just had a 2 on top and a 7 on bottom.
Yeah, I just did it the long way where I wrote all the X's.
No, that's not a long way. That's a different way, and it's great. Long way.
You probably still got that.
That's what she got from the.
Go back.
That's just her showing how she got the X on the bottom.
Oh, so that's what
That's not part of the answer. She's just
So you
showing
got-
how she got X on the bottom. So that'll make that two.
Is that better?
But what about the?
Which way did you try, Michaela? I want to do it your way.
I didn't even attempt them. I didn't.
Okay, let me show you another way then. Okay, because you obviously don't like that way.
No.
I don't know.
That's the way we did it when we did it in class.
I don't get how you just like
After you-
just started scratching numbers out. Like suddenly it was all.
Yeah, how'd you all of a sudden get 2?
And then
Yeah, where'd you get 2 over 7?
I'll show you. Again.
I didn't know what.
I did this pair first.
So that's 1/2.
Okay. Now I've got this pair,
So 4 over 2,
which is what?
2.
So on the top, 1 times 2. On the bottom, just a 7.
I see
You
what
got
you're
the
saying.
X
now. I
and
get
the
it.
Y.
Okay, wait.
Yeah, I got that now.
Okay, let me write it. I was going to show the other way to do it. Let me go ahead and write it again. Okay, so same problem. Because this is just straight multiplication, so if I went across the top, 3 times 4 is 12. X cubed times y to the 5th is just x cubed y to the 5th. On the bottom, 6 times 7 is 42. Y squared times x to the 4th is just putting them by each other. Okay, now I look for how I can reduce 12 and 42, and I know I can take a 6 out of both of them. 12 divided by 6 is 2. 42 divided by 6 is 7. Okay, on my x's, 3 minus 4 is -1. Since it's negative, it goes on the bottom. On my y's, 5 minus 2 is 3. Same answer. Which one's better? They're the same.
See, I did the one where you like wrote all the X's and Y's and stuff, so it
Okay.
took me a while. But the way you showed before where you just,
How did you get rid of the 4?
I did this from a different way now.
Yeah, that's the way I did it, but I just didn't reduce it right.
So on the exponents, it's division, so you subtract. So with my x's, I got a 3 and a 4. 3 minus 4 is -1. Since it's negative, it goes on the bottom. With my y's, 5 minus 2 is 3. You bet your boots. All my scribbling. Well, does that help any? Alright, we ready for 10 just about? Just about. Okay. 10. I've got x squared over x minus 2 times x squared plus 3x minus 10 over x squared plus 2x. Now, what's different between this problem and the previous one was all monomials. It only had stuff on it that had one term like this top left. Now I got a monomial, a trinomial, a binomial. So when you get bigger polynomials, our goal is going to be to factor everything we can, so then we can ninja out whole parts. Remember, you can't start picking apart things. It's got to be, if it's a binomial, you got to be able to slash out the whole thing or none of it. Okay, so that's what we're going to look at here. Left side, nothing here can factor. X squared I could write as x times x if I wanted to, but we know that's what that means. So I'm not going to change anything on the left side, so let me bring all that down. Okay, top right. Very good. Lady Jo knows what multiplies to make negative 10, but adds to make positive 3. So it's got to be a positive 5 and a negative 2. Okay, bottom right. It's got a GCF. X. Just be taking X away from both of these. Just leaves you with an X plus 2. Okay, now it doesn't matter which side of the multiplication sign you're on. If you've got something on top and exactly the same thing on bottom, you can get your ninja sword out. So, only thing I see that's exactly the same is right here. Right? Now, there's another reduction I can do. Because this x squared is a monomial.
It's the same thing
and
as
this,
those two.
this x is a monomial. So what is x squared over x? What can I do with that? Okay, good. On the bottom. And then this one would just be x.
So it'd be
X squared over x is just x. I can't write an x.
So it'd be x times.
X times x plus 5. Good, Garrett. Over what? X plus 2. All we had on top left was an x and an x plus 5. All we had on bottom, I'm sorry, CJ, there you go. All we had on bottom was an x plus 2. I left mine like that. I did see some people that distributed that x back on top. That's correct too. But save yourself some work if you want to and just leave it like Garrett said.
Wait, so how'd you get rid of the x?
X squared over x, or reduce x squared over x. Yep. X squared on top, x on bottom. What's x squared over x? That's where I got that x that's out front.
Oh, I see now.
You got it, you got it. Right, on 11, gears switch on you because it's a subtraction problem. So far, on 9 and 10, we didn't have to mess with the common denominator. Good news to you, 11 is the only one out of this section that needs a common denominator because all the rest of them are either multiply or divide, right? But 11's not, so we got to be concerned about a common denominator. So let me get it written, and Grant's got us on the right road already.
I already got number 11. Factor down the bottom.
Subtraction. Okay, so we got trinomials, binomials, a monomial. We got it all cracking here, and we got subtraction, and we know we can't add or subtract fractions without a common denominator, so we got to find a common denominator. Grant knows that in order to find a common denominator, we need to factor and see what parts are there. So Grant, how does this denominator...
7 and 2.
Okay, what multiplies to make 14 and adds to make 9 is 7 and 2. Okay, so we know now when we drop down a line here to start writing our common denominator, if it shows up in one of these denominators, it's got to be a part of our common denominator. So I've got to have an x plus 7 on both sides. And I got to have an x plus 2 on both sides. Now let's jump over. We haven't looked over here. Do I have this okay yet? Yeah, I already wrote. Oh, I did put parentheses there. I don't have to write another x plus 7 because I already wrote it, right? So this is my common denominator. Good. Now, on the numerator, this side right, this numerator can factor, but I don't want to factor it yet. Because in a second I'm going to have to do some subtraction, and then the way it's written now, I'll be able to tell if I have like terms to subtract. So I'm just going to bring this thing down like it is. Okay? Well, stop. I'm ahead of myself because I know the answer. I didn't ask you yet. Do I need to do anything? Remember, if I multiply something on bottom, I got to multiply something on top. Did I change this left side?
No.
No. I just wrote it in a different form. It's the same.
Yes.
So there's nothing new down here, so I don't put anything new up
But
here.
you have to do it to the 8.
Yes, let me get there first. So I'm just going to bring that down and let me get caught up with Grant. Okay, now over here with the 8, there was only an x plus 7 originally on bottom. We stuck a new x plus 2 down here, so that means we got to do that on top also.
So it'd be 8 and then x plus 2?
Uh-huh. Now, since we got a subtraction problem, we're going to distribute that 8 here so we can subtract like terms. So we're going to know
8x plus 16?
8x plus 16. Okay, so we can just subtract our like terms now. I got an x squared, but there's no x squared over here, so that's just x squared minus nothing. Now I got a 1x minus an 8x.
So 7x.
Negative 7x. Then I've got
Oh.
a negative 6 minus a 16.
It's minus.
Negative 6 minus 16. Negative 22. All over my common denominator. Now, when we did this in class, sometimes we were done, sometimes we weren't. But when we would not be done is if I could factor that top and ninja anything out on the bottom. So, is there anything that multiplies to make negative 22 but adds to make negative 7? No, 22 is 11 and 2, and you can't make a 7 out of an 11 and 2. So that's your final answer. If you wanted to write the denominator different, you could have written x squared plus 9x plus 14 on the bottom, if you wanted to.
You want to be that different kid.
Yep. There, when I was a little tight on Sesame Street, there was I think it was Sesame Street, it might have been the electric company. I don't know. There was a segment, one of these kids is doing his own thing. That was always me. One of these kids is not like the rest. You had to pick out off the TV screen. Which
You
kid
have
was
60 at You have to do it 3 times 10.
That'd be you nowadays.
I couldn't do it the road way.
It's because I'm just cool like that. Not everyone can be me.
Alright, on 12 now, we're back to multiply. So we only get a common denominator, we might can ninja
There's
something.
so many of
We
them.
ready for 12? X squared plus 3x plus 2 over x squared minus 1 times x squared minus 6x plus 5 over x squared plus 5x plus 6. Okay, in a nice, perfect world, maybe we could mark out whole trinomials, but they got to be exactly the same. So I don't have anything exactly the same to mark out. So I got to start taking it apart, lay my bicycle parts out on the carport floor, and see if I got any parts that are the same. So on the top left, by the way, all 4 of these pieces can factor. On the top left, what multiplies to make 2 but adds to make 3?
2 and 1.
Good. X plus 2 over x plus 1. Keep going. Bottom left. This is perfect square minus a perfect square. Difference of squares. How does difference of squares factor?
Plus and minus.
Good. One of them gets a plus. I've left on one out. One of them gets a plus. One of them gets a minus.
How do
Square
you
root
know
of-
one's supposed to square?
Both of them are perfect squares, and it's got a minus sign between them.
So if it had a plus, what if it had a plus?
They factor. There's no such thing as
Wait,
sum of
which one?
squares.
Oh,
So you would just leave it x squared plus 1?
Mhm.
Okay.
Okay, everybody okay? Top right, what multiplies to make 5? This one might trick some people. Adds to make negative 6.
5.
Good. 5 is only 1 and 5. So you got to figure out how to make it a negative 6 so they both have to be negatives. Doesn't matter what order you put them in. Okay, last one, what multiplies to make 6 but adds to make 5?
3 and 2.
Uh-huh. Now, anywhere, if we've got the same binomial on the top and the same binomial on the bottom, it doesn't matter which side, it's just going to be top and bottom, you can get your ninja sword out.
You can ninja x minus 1,
Okay, what else?
X
x
plus
plus
1.
1.
X plus 2. And you're left with x minus 5 and x plus 3.
Yes, sir. That's it. Good job.
It's actually making sense.
Say that again, Eric.
It's actually kind of making sense now.
Good. Sad it took so long, but good. Better late than never.
shoot.
I'll make a B on this test. Let's go.
Let's shoot for an A.
Shoot, I'm shooting for a B. If I make a B, I'm gonna be walking out here proud.
I'm shooting for a C.
Y'all
The best I've done is an 80, and that was the first week of school.
You gotta give yourself a smidge more.
I made a
There's been
52 last
there's
week.
been 3 lessons probably that like I can only do like 40.
That
I made
one was
100 on
hard.
the last test. This one is
And I'm just gonna throw this at you to make you mad and make you not like me even more. 98% of the stuff we've done has not been new.
yeah, but I didn't learn it anyway. Like a while ago.
Okay, so we got all monomials here, so this is very similar to number 9. The difference between this and number 9 is that this one's a division and 9 was multiplication. But that's not a big deal for you, because you know how to change this to a multiplication problem. Good. Keep the first one, keep the first one, keep the first one. I don't like writing a J. I don't know why. Keep the
Why would we
first
just
one.
randomly add a J?
I don't
We're
know.
fine with our X's and Y's.
Change it to a multiplication problem. Take the reciprocal of the second one.
Just flip.
Now it's just like number.
Wait, why would you not flip the first one?
Keep the first one. That's what you always do. That's, I don't know why. I didn't make up the rules. You always keep the first one like it is.
Oh yeah, keep change word.
Yes.
I really think you should have been at that math class.
I was old enough. I don't know why they didn't invite me.
J squared.
Ah.
Oh.
Oh, I remember.
This is up to you, just like on number 9, on how you want to do it. I'm going to start with my variables. Okay? So let me get a highlighter this time. Maybe that'll help. If I start with my h's, I've got an h cubed over an h. 3 minus 1 is 2, so that means the whole h down here would go away. This one would turn to squared, because 3 minus 1 is 2. Okay, let's go to my j's. Let's grab a different color highlight.
That
BJ squared.
J3 would cancel and be J over 2.
Okay, 3 minus 5 is negative 2, so this whole piece goes away. This one down here would be a 2. So far, I'm going to have an h squared on top and a j squared on bottom. Now do whatever you want to with these numbers. You can multiply 3 times 21, 7 times 18, and then divide them. What I did was just kind of reduce some diagonal stuff. 3 over 18 is the same as 1 over 6.
Yeah, I couldn't do that.
You don't have to do that. That's okay. 21 over 7 is the same as 3 over 1.
Stop.
Okay? Now that can reduce again.
1/2.
Very good. 3 over 6 is the same as 1 over 2.
Do you always have to go diagonal?
Say that again?
Do you always have to go like diagonal?
No. I was just looking for friendly numbers. So you could have done, you could have reduced the 18 over 21 first.
So what's 7?
I see what you're saying now.
126.
So if you did 3 times 18, and you did 7 times 21, and then divided those, you should get 1/2, which is what I got doing my little pieces.
Yeah. It'd be 63 over 126, and that's what equals 1/2.
Yep, very good.
What would you divide it by?
63.
63. You'd multiply it and then divide it by itself.
Yeah.
There's not a J on the test, is there?
I really don't remember. If there is, just change it to whatever letter you want.
Okay, so you got 3.
Thank you, Angel.
I was wondering why I got corn.
Well, Tori's still thinking too, but I was
Yeah,
listening to
I'm
you helping Grant.
You
Well, then don't do it that way.
Then how do you do it different?
You just
Multiply across the top.
and then set the top.
3
I did
times
that,
21.
but I still got the wrong
63.
3 times 21 on top, and 7 times 18 on bottom.
I think it's
63 over 126, and then that reduces to 1/2.
what? Those are different answers then.
Or not. This is 1H, so that's 1/2. She was just asking about the numbers. That's all I was showing. All right, on 14, there's not a whole lot to do on 14. I think they could have made 14 be a better problem if they'd have made it division. Then you could have at least got to ninja some stuff out, but
Yeah,
like,
I kind of got to ninja very much.
yeah, but like it is on 14 with the multiplication, nothing is exactly the same on top and bottom. Yes.
Sorry, I have one more question about that. Is it okay if you have the 1 there, or do you need it?
1H squared is the same as H squared. Okay, if this had been division and I could have switched this right side to its reciprocal, I could have ninja'd some stuff, but it's not. So all I could do, there's nothing to mark out. So on the top, 1 times 3. On the bottom, x plus 2 times x squared minus 4.
Wait.
Wait, what did you just do?
Oh, I see what you did. You did 3 times 1. You got 3 on top, and you just brought everything over.
Yeah, because there's nothing to ninja out.
That's easy.
So you pretty much just wrote the problem.
I think they should have made that a division problem. It would have been more interesting.
No, we like the feedback.
So if it was a division problem, you'd flip.
Uh-huh.
It'd be
And
x
then-
squared
Uh-huh.
minus 4 over 3.
Yeah, let me just do it because this is cool. Uh-huh. So this would be, if this were a division problem, I don't know what I'm trying to write.
Okay.
Times x squared minus 4 is x plus 2, x minus 2. So then you could have ninja'd the x plus 2's, and you'd have just been left with x minus 2.
Oh.
3, yeah, I wrote the problem wrong. Over 3, thank you, Laney Jo. Alright, now once you hit 15, bless you, bless you, bless you, you got all the word problems. So read through 15 there, especially you had to come up with an equation to write on that. It's the way I did it, especially Muffin Company makes muffins for 12 cents a muffin. So I know I'm going to have 12 cents times however many muffins I make. They got a startup cost of $300, so it's going to cost me 12 cents a muffin plus the $300 to start the company. How many muffins must they make before they end up costing 25 cents a muffin? So if we want this whole thing
Wouldn't you put it over 0.25?
close, we're going to set it equal to 0.25 because that's how much we want each muffin to cost. So I've got to do this 12 cents times how many muffins I make plus 300, then I'm going to divide that by the number of muffins I sell. If I sold 10 muffins, I divide it all by 10. If I sold 20 muffins, I divide it all by 20. So now you've got your rational equation to solve. So what I did is just like we did in class, this is just a fraction equals a fraction, right? So I cross multiplied. I got 0.25x is equal to 0.12x plus 300, and now you just got a regular two-step middle school equation to solve. What would our first step here be?
Minus 300.
No, I could, but that would create extra steps.
Oh, subtract the x.
Yeah, subtract the x since I got 2 of those. Now Grant wouldn't have been wrong with the minus 300. He'd have just then had to do another step. So that would get us 0.13x is equal to 300.
Divide by 0.13.
Divide by 13.13. Now it tells you on here that we're going to round to the nearest whole number because this is a number of muffins. So I did that and I got like 2,307.7. So I'm not going to sell 7/10 of a muffin. So to end up making that money, I need to round that up to the next whole muffin. So I would need to sell 2,308 muffins. family's taking a summer vacation, the cost of the vacation to be manageable, you determine it'll be best interest if you split it with other families. The cost C in dollars per family of the vacation is inversely proportional. I told you as soon as you read inversely to write your equation, it says cost C varies inversely with the, what letter did it use? Number of T for number of families. So it's just like y equals A over X, but they told you to use a C and a T. Okay, so keep reading. Your family wants the cost of the house per family to be $600. Cost $600
It's equals 600.
equals A divided by. Currently, there are 3 families, including your family.
So 4. Oh, no. Including.
3. So to solve that for A, you would multiply by 3. So our A is 1,800. Okay. So the vacation, when there were 3 families, the vacation rental was 1,000. So 1,000 equals 1,800 divided by T. So we got to figure out how many families. T. What we got to do?
Multiply 1,800.
No.
When you divide? 1,800?
Isn't this problem just like when we just worked? Don't I have a fraction equal a fraction?
Oh, cool.
So 1,000 T, I left a 0 off, 1,000 T would be equal to 1,800.
And then divide by.
So divide by
So you would divide.
1,000.
Be 1.8.
Okay, now again, T does equal 1.8, but 1.8 families aren't going to go. So
two.
how many more families do we need? 2.
families.
So key for you on that I would underline on your study guide is the inverse, and then that you wrote down the inverse equation.
More.
Yes, sir. Are we already ready on 17?
I'm ready for 17.
Let me get it written. Get caught up. Okay. So they give us these 2 things on number 17. It says, first off, to simplify that rational one and determine whether the graph of that and the other one are the same or different, and explain.
Wouldn't that just be x minus 8 because you can cancel out
Okay,
x plus 2?
so over here on the left, so you do end up with y equals x minus 8, which does appear to be the same as what we're comparing it to.
Yes.
But the graph of the one on the left has got a restriction, and the graph of the one on the right does not. Okay, that's what it's asking us to figure out. If I were to graph this one, this is a line, this is slope-intercept form. Its y-intercept is -8. Y equals mx plus b, -8. It has a slope of 1. So it would be a line that, I almost hit them. It would be a line that looks like that. This one has a restriction. What number can never be on the bottom of a fraction? 0. What value of x would make this 0? 2 plus 2 is not 0. -2. So what I would need to write about on this, whatever number we're on here, 17, is that, yes, it does simplify to the same thing, but on that one, x cannot be -2. So what we have not done, and we will before the year's out, what we've not done on a graph is talk about a hole. A hole in a graph. There can actually be a hole in a graph. If we were to graph that one on the left, where x is -2, there would have to be an actual hole in that graph.
So it simplifies the same, but
Simplifies
x
the
can't
same,
be
but
-2.
on y, x cannot be -2. Does that grant what you kind of had? Simplify the same?
Yes, ma'am.
Good.
I was like, he gave me the answer right there.
Alright, 19 had me scratch my head for a second, but it wasn't too bad after I got rolling a little bit. Everybody good on?
We got 18.
That's what I mean. I'm sorry, 18. Yeah, I was looking at the table tennis balls and said the wrong number. Thank you, Miss Riley. It says, write an expression for the volume V of the rectangular box in terms of the radius R. Then rewrite the formula to express blah, blah, blah. All right, so a rectangular box, the volume of that is length times width times height. So you've got to be able to look at those 5, they're supposed to be touching, put one there, make them kind of touch. You've got to be able to look at those 5 table tennis balls in the box and use that R to figure out your length, your width, and your height. So if half of a table ping pong ball is R, how many R's would there be all the way across the box? Okay, because you got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Very good. So you've got a length of 10. How many R's tall would the box be?
Then what?
2, right? Because the radius is 1, right? So you would have 1, 2. So times 2. How deep? How many R's deep would the box be? Lane Joe's right. Can y'all look at your paper? I can't draw
Well,
3D.
if they're a ball, it's all the way around.
Right.
the
So
same
the
number,
R. So it's 2.
Yeah, that's
Okay.
what I said, but
Okay. So the volume that we're looking at on this 10 times 2 is 20 times 2 is 40 R's cubed, right? Because each of these, this is 10 R. I didn't write it very good. That's 10 R's, 2 R's, and 2 R's. So R times R times R is R cubed, right? So the volume would equal 40 radiuses cubed. Okay, so we'd be looking at a pretty good A answer on that. Then part B says, find the percent of the box's volume that's occupied by the tennis balls. What I had to think about a little bit, percent, I kind of related it to a test question. If you got 8